Hey everyone! A little while back we covered how to make Matej Baglietto's hex world using Blender's geometry nodes. A lot has changed with geometry nodes since version 3.0. In my opinion, they seem to be way more intuitive than the pre-3.0 nodes, and have a more similar flow to the material nodes, which I like. So let's take a look at how we can set up this scene using the new geometry node system. We're not going to be using this light, so let's delete that. And I like using orthographic view with numpad 5. A lot of people have requested that I use screencast keys, so I'm gonna turn that on. Now you can see what keys I'm hitting in this bottom corner. So let's add a sun to our scene. The position of a sun object doesn't really matter, just the angle, which I'm gonna set to 45 degrees on the y-axis. In this menu, you can adjust your light settings, but I'm just gonna leave everything as default. Switch over to the Render Properties tab, and let's make sure the render engine is set to Eevee. Our lighting options are a little different in Eevee, but again I'm just going to leave the sun with the default settings. Back in the Render Properties, enable Ambient Occlusion and turn up the Trace Precision. We also want to turn up the shadows. Under Color Management, I'm going to switch the View Transform from Filmic to Standard. You have to be careful with the standard setting when creating a 3D scene. Surfaces can look really blown out if the lighting is intense. In the World Properties tab, let's adjust the background color of our scene. I'll put the hex code on the screen somewhere in case it's too small to see. So now we need to build the objects we're going to use in our scene, which includes the hex object, grass, tree, and rock. Let's start with the hex object. We could turn this default cube into our hex object, but that's just too much work. So unfortunately, delete the default cube. Let's create a new collection in our outliner so we can at least attempt to keep the scene organized. Name it something that makes sense to you. Move the sun out of the way if it bothers you. And let's add a circle. Open up this Add Circle menu over here and change the vertex count to 6. I want this hex object's sides to stretch from -1 to 1 on the background grid, so change the radius to 1.15 meters. And you can change the fill type to N-gon so that it autofills the circle with one face. Tab into Edit mode to confirm this shape. If it's all orange, it's selected, but if it isn't, hit A to select everything. Then extrude and hit G, type -10 to move the new face down 10 units. This is very close to being done. I want the shape to feel more natural by removing the perfectly angled edges with a bevel modifier. So let's head into the Modifier tab and add a bevel modifier, which will also help the corners catch the light in a more interesting way. Change the segments to 3, adjust the amount, and since we want our hexes to fit together without any spaces, change the angle to 60 or greater so the sides don't get beveled. And that's the hex object. I'm eventually going to build the hex world at 0, 0, so I'm going to move my objects away from the center of the scene. Make sure to move it in object mode so that our object origin, this orange dot, moves with the object. Now use Shift S to move the cursor to selected. Name this object, I'm going to call it hex, and let's make the grass object. Add another circle, shrink the radius slightly, and that looks good to me. Tab into Edit mode and move everything up a tiny bit. In Edit mode, change to Vertex Select up here. Hold Shift and select these two vertices, hit J to divide the space into 2 quads. We're going to replicate the effect we used in the previous video on the grass, which will work a little better if we start with 2 faces instead of 1. In the Modifier tab, add a Solidify modifier. You can disable the visibility of the hex object in the outliner if that helps, and adjust the thickness of the Solidify modifier. Now let's add a bevel modifier, and turn back on the hex object. We'll come back to the grass later once we get into the geometry nodes, but for now it's done. So now let's make a rock, which is pretty easy. Add a cube, scale by 0.1, and add a subdivision modifier. Go into the face menu, shade smooth, and it's done. Name the new object rock or whatever you want to call it, and also name the grass object while we naming things. And let's real quick make an object to instance our rocks on. There are a lot of ways to distribute our rocks within our hex world using geometry nodes. One way is to create an object with predetermined points where the instances can appear. Any vertex will be a location where a rock can appear, so you don't have to use any shape in particular. If you'd like to make it like I did, add a plane, in wireframe view add a few edge loops with Ctrl R. Turn on proportional editing, switch the mode to sharp, select the 4 corners and scale in. scroll the mouse wheel to change the fall off. Try to get a sort of circular grid. And then select all and scale it to fit on the hex. Name this object and we can move on to the tree. Add a circle. The diameter doesn't matter, but I went with 1 meter. Change the vertex count to 32 and switch the fill type to nothing. Now just shape the tree trunk by resizing and extruding. Make sure to turn off proportional editing. Duplicate this upper loop and use it to build the tree shape. At this point, hit F to fill in the face. And then extrude up a loop on the Z axis and merge at center with M. Hit Ctrl L to select all linked vertices and duplicate this object to make the second tree tier. If you're an overachiever, you could make these shapes into separate objects and use geometry nodes to build tree variations. And then make one more tree tier by extruding and scaling circles. I keep the top rounded a bit rather than merging all together on this tier. And then just adjust the scale of everything until you like it. In edit mode, select all with A and shade smooth in the face menu. The shading looks a little bit bad right now, but we'll fix it with a bevel modifier. And I'm just going to leave the settings as default. Alright, tree complete. Don't forget to name it. So now we need to make the object that determines where the trees can appear, just like the rocks. Add a plane. Put the vertices wherever. And rename it. At this point, we can turn back on the visibility of all of our objects. We covered the materials pretty extensively in our previous video, so I'm just going to show the finished materials here. This is the hex material. Depending on the Z location, it changes from water to dirt color. This is the grass material, which also based on the Z location changes from grass to even grassier colors. This is the tree green material, the tree leaves. The green stuff on the trees. The tree trunk is utilizing the hex material. And this is a rock. Material. Now that all the instance objects and materials are finalized, we can actually build the hex world, which is surprisingly easy. We want to move our cursor back to 0, 0, so hit Shift S and choose Cursor to World Origin. Add a plane. Name it something, like World. Tab in Edit mode and select these two vertices, merge them at center with M, and do the same with the other two. Select all and rotate by 30 degrees. And that's actually all it takes. We just need some modifiers and geometry nodes now. So a good place to start is the grass object. Go into the modifier tab and add a geometry node modifier. Over here, move the new modifier into the first position. It's important to note that modifiers are applied to your object in order, so positioning matters and changes the end appearance. Let's switch this bottom area to the geometry node editor, and here's our geometry nodes. If you remember last time, we used an attribute mix node to mix randomized texture values into our object's normals to make it look bumpy. That node no longer exists, but we have a lot of new nodes, so let's figure out how to do something similar. I'm going to turn off the visibility of the other objects so I can see the grass better. First, we want more geometry to work with, so let's add a subdivide mesh node and turn it up to 2. And we want to adjust the position of our geometry, so find the set position node and add it in here. If I adjust the offset fields, you can see the object slides around. If we take a quick look at the set position node, these input sockets are diamonds, and this one is a circle. This is the major new thing with the geometry nodes. Circle sockets input and output single values. Diamond sockets, such as position, are fields, which means each element can have its own values. So in this instance, each point has its own XYZ position. And diamonds with dots are fields that currently only have one value. But since they're diamonds, they can accept fields. So the diamond by the offset input tells us we can compute the position or offset of each vertex on our object individually. If we go into wireframe mode, you can also see how the subdivide node is affecting the mesh. It's just adding more geometry. So we want to use the position of our geometry and mix it with the normals, which we can do with these two nodes. And we can add procedural textures directly into our geometry nodes, so add a noise texture. Last time we used an attribute mix node, but that no longer exists, so weirdly just use a mix RGB node. It accepts vector fields and outputs them, so it'll work exactly the same. Connect our two attribute mix nodes to the color inputs, and the texture nodes factor to the factor input. We can use either of these inputs to do essentially the same thing. Connecting to the offset input will add to our original position. Connecting to the position input will forget our initial position and override it with what we put in. Since we have the position node being piped into the mix node, this isn't an issue. This texture is displacing the positions a little too extremely, so add a math node here, switch it to multiply. And drop this number to something very low. Since I don't want my grass to look like it's made out of folded cardboard, tab into edit mode, select all and shade smooth. And there we go, grass complete. If you want to, you can lower this into the hex object slightly in edit mode. I accidentally did it in object mode, which won't actually lower when we instance the grass later, but I didn't notice until editing the video, but it looked fine either way, so you can do it if you want. Alright, so that's the grass, and a little intro into the new geometry nodes. So let's build the hex world. Select our world object over here, which currently just looks like a line. And the best place to start is probably by adding a geometry node modifier. Add an instance on points node here. And while holding shift, drag the hex object from the outliner down onto the geometry node editor. Connect the geometry node output to the instance input. And if you have everything scaled correctly, it should line up pretty nicely. Add an array modifier and move it into the first position. Change the X factor to 2 and increase the count to anything that you want. Although your computer may explode if you raise this number too high. Speaking of which, it's probably a good idea to save your project at this point. Add another array modifier, move it in the second position. Change the X factor to 0 and the Y factor to 2. Adjust the count to as high as you want. This time, higher numbers are even more dangerous, since we're arraying an array. So last time we used the displace modifier to give our world height. We'll start by doing that again, but later I'll show you how to do the same thing using geometry nodes. Add a displace modifier, move it above the geometry nodes, and it's kinda doing something cool looking already. We want to use the coordinates from an empty to control our displace texture, so in the 3D viewport, add an empty. Click the world object again, click new here, and change the coordinates from local to object. Select the empty as the object. It's not actually doing much yet, so let's set up the texture. Click this button to go into the new texture we've created, which is down here in the Textures tab. Switch the type over to Clouds, and I'm just going to set this up exactly as I had in the last video. Watch as the texture changes. This is essentially a height map of our terrain. Black will be water, and the lighter colors will be the higher elevations. This looks pretty cool actually, but it's not quite doing what we want it to. So switch back to the modifier tab and change the displace direction from normal to Z. Go back into the texture tab. Turn on the color ramp. Click over here and get rid of the alpha transparency, even though it doesn't matter. And add a few more stops to our color ramp. Switch it over to constant. Now our color stops determine the positioning and height of each hex according to our texture. The position of each height bracket on our texture is determined by each color stop's location on the ramp. And the height is determined by the gray color we choose for each stop. I'm just going to try my best to set it up like we had the first time. At this point I noticed that a lot of the tiles are watercolored, which at first I thought might be an issue with the material, but it wasn't. The only other thing it could be was the displace modifier. Almost all the tiles are below 0 on the Z-axis, so select the world object and go back into the modifiers, and make sure that the mid-level is set to 0, and that looks more like it. Head back into the texture tab and let's fine-tune the colors with everything working. We can only get gray values between 0 and 1, so at most the color ramp can offset our hex grid to a height of 1. You can change this by adjusting the strength of the displace modifier. Setting it to 2 will give us tiles ranging between 0 and 2 units high. And we're using this empty to get our texture coordinates, so moving, rotating, scaling will alter how our grid looks. I recommend scaling the empty up quite a bit, which essentially zooms in on our hex map. If you're like me, you'll probably want more hexes, so increase the counts on your array modifiers. And zoom in way more. This is looking pretty good, so let's work on our geometry node system. Select the world object and select on the geometry node modifier. Make sure the geometry node editor is open in this bottom area. If we zoom in and look at the textures, you can see all of the hex objects are facing the same direction, so let's mix it up and rotate our tiles. A circle is 360 degrees, hexes have 6 sides, so let's rotate by random 60-degree intervals. Add a rotate instance node here, and make some room for a few more nodes. Under utilities, add a random value node and a math node. Switch the mode to snap. In the random node, generate a random value from 0 to 360 and snap it to 60-degree increments. We need to duplicate this node, change our value to radians, and we only want it to rotate on the z-axis, but I'll show you what it does as is. It's randomly rotating the hex objects on all 3 axes. So let's add a combine XYZ node, connect the value to the Z input, and when we connect this to rotation, we'll see the hex objects all rotate randomly. So that's all we need to do for the hex grid. Let's select all of these and group them up with Ctrl-G for organization's sake, and then hit Tab to exit the node group. You can label the node group over here, hit N to bring up this menu if it isn't here. As I say constantly, there's hundreds of ways to do everything, but what we're going to do is run parallel geometry nodes for most of this, rather than daisy chaining it together. So we'll need a join geometry node at the end to link all of our chains back together. Now let's grow some grass. It's going to be very similar to the grid. Add an instance on points node, and connect like so. Shift drag the grass into the geometry node editor and connect it up. Right now every point has a grass object, but we want to narrow down where the grass instance is, which we can do with the selection field. It's a pink diamond, so it accepts Boolean values, which means it's true or false. You can also think of it as on or off. We want to find each point's Z position, and then use the compare node set to greater than to instance grass on any point above the value we set. I want water and shore tiles without grass, so for me, point 4 will put grass on every tile except for the 2 lowest tile heights, but you can just slide it around until it looks right. And in the previous video, I believe we randomly rotated the grass by 60-degree increments as well, which is exactly the same as we did with the hex tiles, so drop on a rotate instance node, and then tab into the hex world node group and copy these 4 nodes with Ctrl-C. Tab out and hit Ctrl-V to drop them here, and connect up to the rotation. It's not a very noticeable change, but it mixes it up a bit. Get these nodes all organized by moving them around. And we're done with the grass, so select and make a node group out of these nodes, and name it grass. Next we'll get some trees in our world. This will be slightly different than the hex grid and grass, but the same overall concept. Add an instance on points node, and shift drag in the tree locations. Add another instance on points node, and this time, shift drag in the tree object. And now on every hex we have a tree location object with 4 trees instanced on it, so it's a good start but needs some work. So first let's start by getting our Z positions, and using a compare node to choose points with a Z location greater than 0.4 as our selection. But we also want to randomly choose tiles from within this selection. So add a random value, and duplicate the compare node. Greater than or less than are basically the same in this situation, so use either. Switch to 0.5, and add a Boolean math node. Drop it here, and connect the random value to the bottom input, so now both of these statements have to be true for the output to be true. I discovered later after recording this that you can switch the random value node type to Boolean, which will cut out the need to use the compare float node. So of the tiles with a Z height higher than 0.4, a random selection of half of them have a tree location object instanced on it. And you can change this value to adjust what percentage of tiles have trees, anywhere from 0% at 0 to 100% at 1. To keep this organized, drop a frame node in here and move all of these nodes into it. You can name the frame node over here while it's selected. Make some more room, and we want to add some variation to this by randomly rotating our tree location instances, which is just like with the grass and hex tiles. So go into one of those groups and copy these 5 nodes. Tab out and paste them. You can't drop nodes onto lines if anything is connected to them, so disconnect this node, and drop the rotate onto this line, then connect it all back up. And now our trees have some rules to where they show up, but look somewhat random. Now we want to randomly select which points on our tree locations to instance trees on, which is very similar to what we've done a few times now. Add a random value and a compare node. This time, however, something strange happens. At 0.5, nothing shows up. If we set the value very high and zoom in, you can see that as we change the value, each tile with trees has the same trees showing up. So the exact same changes are being applied to each tree location instance. Although the rotation helps mask it a bit, we want it to be even more random looking. So we somehow need to make the instances real between this point and this point, which we can do with a Realize Instances node. And now each instance is randomized with an assortment of twees. And we can populate or deforest the world by sliding this less than node. I'm going to go with 0.5. Drop these new nodes into a frame, call it trees or something, and make a node group out of all these nodes. So now all that's left is rocks, and it's very similar to trees. Instance on points, rock locations. Instance on points the rock object. Many rocks everywhere. Let's use some selective positioning and compare values with Boolean math to choose random tiles to place rocks. So here it is. I only want them on the beach, so I used a greater than and less than here to get only points between these two values. And then this node chooses random tiles within that selection. Don't forget about organization. We should realize these instances if we want each tile to have a different selection of rocks. Now add all the nodes to get the random selection. I want a high amount of shore tiles with rock locations, and a low amount of rocks per tile, so that I get a nice, even spread of rocks. With the rocks, we might want to randomly scale them a bit, which is also very easy. Add a scale instance node here, and add a random node here. This will scale the rocks on all axes evenly. You can switch this random value from float to vector if you want each axis scaled separately, but I quite like the look of this. As you can see, elements are really easy to add and pretty intuitive to adjust. If you're ever confused on what a node does, check out the Blender manual, it's quite helpful. One last thing to cover, which I mentioned earlier, was how we can replicate what the displace modifier does within the geometry node tree. So let's disable the displace modifier, add a geometry set position node here. We're going to set the Z position of each point using this node. And we're going to use this empty object to control the texture as well. So shift drag the empty into the geometry nodes. Add a noise texture, which will act as the stand-in for our cloud texture from earlier. Connect the noise texture factor to the offset and change the scale to 1. If we zoom in a bit, you can see that we're offsetting all of our axes, which we don't want. So add a combine XYZ node here, add a vector math node, and add the position to the empty location. Duplicate the vector math node and switch to divide. Connect the empty scale to the divide node. And now scaling the empty scales the texture. But currently if we move the empty, the texture moves in the wrong direction. So switch the add node to a subtract node, and now it's all working well. So now we need a color ramp set to constant to make all the different height bands we had with the displace modifier. It'll have to be set up slightly different just because the texture is different and we don't have contrast controls or anything. And we can add a math node set to multiply here to basically do what the display strength setting did. Since the color ramp only outputs values between 0 and 1, this will multiply those so we can get some more height in our world. So have fun choosing tile heights and whatnot, and you can do all sorts of cool things with the color ramp. Thank you for watching, I hope you enjoyed. I love this hex world thing, and hopefully you guys enjoy adding little extra randomized elements. You can put little villages in and stuff, it's really fun. Please like, subscribe, and leave us a comment on what you'd like to see us make or if you have any suggestions. If you'd like to help the channel grow, share the video. We also have a Patreon. Thank you again, stay safe, I love you all, goodbye! Goodbye.